Alright, let's start. Organic chemistry, organic chemistry, organic chemistry. Organic chemistry, organic chemistry is the chemistry study of carbon compounds. Chemistry study of carbon compounds with few exceptions of certain compounds of carbon, certain compounds of carbons like oxides. And the oxides of carbon we have CO and CO2. So these are compounds of carbon that are not organic. So organic chemistry is all about the chemistry study of carbon compound. But there's exception to that. By exception, we mean there are some compounds of carbon that are not organic in nature. Carbon is the central atom of an organic chemistry quite product because of the way, the manner with which it link up to several elements. So you have oxide not being among the organic aspect of carbon compounds. So we also have sulfides. Sulfides. By sulfides, we mean carbon disulfides. We also have carbides. Carbides. By carbides, we mean carbides of metals, carbides of metal like calcium, bicarbides, and even carbonates, and bicarbonates, carbonates and bicarbonates, etc. These are compounds of carbon that are not organic but what inorganic. So organic chemistry is all about the chemistry study of carbon compound. And why do carbon? What is so special about carbon atom that make it to be the compound of an element of interest in organic chemistry? Number one, because of its ability, the ability of carbon to form multiplicity of bonds with itself and other elements. This is a special ability that we call catenation. So carbon form bond with itself and other elements. I mean, it marry itself and also marry both metals and non-metals. So, and we call that special ability of carbon catenation. Catenation. That is the ability of the carbon atom to link up with itself and other elements. They link up with itself by forming either carbon-carbon single bond, carbon-carbon double bond, or carbon-carbon triple bond. So these are the various ways that carbon link up with itself. They also link up with other elements. With oxygen, it can form carbon-oxygen single bond this way. That is in terms of what we call ether or Akashic alkane. So you can also as well see carbon double bond oxygen in terms of your carbonates. You can see carbon triple bond nitrogen in terms of your nitrile, or cyano alkane. All these are the various ways. So carbon form numerous compounds because they have this special ability for catenation. Another reason we should consider here is carbon, the position of carbon in the periodic table. Carbon is positioned in the second row and fourth column in the periodic table. That is why it is a period two elements and group four elements. That is it. With the electronic configuration of 1s2, 2s2, and 2p2. That is the electronic configuration of carbon atom. So it is positioned in what? Second row and column 4. And it is in the middle of this position. And carbon is positioned in such a way that element to the left hand side of the carbon, which are your metals, have the propensity to donate electron. While those to the right hand side of your carbon in that position in periodic table have the propensity to accept electron. So with this, carbon C, just like Egyptian pursuing behind and the Red Sea at the other side, see it. So Carbon said, no, I rather establish an agreement between both parties. So he share, Carbon share electricity. He neither donates nor accept. He do not accept, neither does he donate. But he do what? He share electricity. So that give it that propensity to form varieties of compounds and all that. So that is it. The special ability that carbon has. The position in the periodic table. And remember, carbon is tetravalent in nature. So it is half filled. The atmosphere of beta is half filled. So it is tetravalent, meaning that they are always a carbon atom is always waiting for four things to be bonded across it, something like that. So that is what we mean by being tetravalent. So carbon is tetravalent in nature. So with this, I want us to quickly consider classification of organic chemistry. Classification of organic chemistry. Classification of organic chemistry. By that, I'm classifying organic chemistry into what we call hydrocarbon, hydrocarbon, of course, hydrocarbon with the symbol CXH1, and non-hydrocarbon, non-CXH1, meaning non-hydrocarbon. So these are the way that we classify organic chemistry. And of course, under this hydrocarbon, we are going to classify it into, you know, aliphatic hydrocarbon, aliphatic hydrocarbon, and then, of course, we have aromatic hydrocarbon, aliphatic hydrocarbon, and aromatic hydrocarbon. So that is it. This is the general molecular formula of hydrocarbon, CXH1. Is the general molecular formula of hydrocarbon. With C being carbon and X representing the number of carbon atoms, H hydrogen, Y representing the number of hydrogen atoms that is attached across carbon. So we have aliphatic hydrocarbon and aromatic hydrocarbon. Under aliphatic hydrocarbon, we are going to have what we call another special class called acyclic, acyclic, and we have another one called the cyclic hydrocarbon. The word acyclic means not being circular, you are without circle. That means you form straight chain, whether bent at the end or not, or straight chain that is not in cyclic form. So acyclic means the opposite of what cyclic. So under acyclic hydrocarbon, we considered what we call the parent alkanes. We have another parent alkenes. We have another parent alkynes. Alkynes. So these are the this thing. Now under cyclic, we have your cycle alkanes, and we have your cycle alkenes. Alkenes, cycle alkenes. Remember, this alkane does not have any functional group, but the functional group of alkane is carbon-carbon double bond. Look at this, carbon-carbon double bond. While alkyne, the functional group is carbon-carbon triple bond. Here, like I say, it's carbon-carbon double bond. That is the functional group. By functional group, we mean that part of an organic molecule where most of its chemical reaction do occur. So that is what we mean by functional group. Remember, an alkane has the general molecular formula of CN, H2N plus 2, as that of alkene have the general molecular formula of CN, H2N, and alkyne have the general molecular formula of CN, H2N minus 2. Another name for alkane is what? Paraffin. Take note of this. Paraffin. While alkane is otherwise known as olefins, and alkynes otherwise known as acetylenes. Acetylenes. So under your aromatic have the general molecular formula of CN, H2N minus 6. So that is the general formula of aromatic hydrocarbon. So, but your cycle alkane share the same formula as alkane, as CnH2n H2N. While your cycloalkane have the same formula as alkyne, CnH2n minus 2. Don't forget that when alkane lose one hydrogen atom, alkane that lost one hydrogen atom is called alkyl. Alkyl, and you have the formula CnH2n plus 1. As your alkene that lost one hydrogen atom is called alkenyl. Alkenyl with the formula CnH2n H2n minus 1. Then alkyne that lost one hydrogen atom is called alkynyl with the formula CnH2n minus 3. So the basic thing. Remember, even when benzene lost one hydrogen atom, we call it allyl or phenyl. And they have the general molecular formula of CnH2n minus 7. These are the, of course, remember, aromatic compound are special nature of cyclic compound. Here, there's a property called aromaticity. And for a compound to be considered aromatic, you must obey the rules of aromaticity, which we call Hoppus rule. Hoppus rule. Hoppus rule. All these things I'm going to take them bit by bit, one after the other, and demystify it to the level that you can masticate and stand for your various exams. So Hoppus rule. This Hoppus rule states that the number of pi electron contained in an aromatic compound must follow the order of 4n plus 2 pi electrons. 4n plus 2 pi electrons. So that is a rule. And remember, for compound to be aromatic again, you must be planar and cyclic. Planar and cyclic. So all these things are going to take them different. I just want you to have a picture of what you are going to be considering. This is just under hydrocarbon, and more will be added. This one is just an excerpt from the plenty things that we'll have to discuss. So I just have to present this one. I want you to follow me closely on this matter. I'm going to be taking you on the various aspects of your chemistry, not just organic. So the only thing you need to do this time around is, go on to my YouTube channel and subscribe. Not only that, turn on your notification button so that whenever I make a new upload, you will have access to it full time. Because I'm going to be doing brief and to the point summary of all these things as you'll be seeing it in your exams. So that's how it's going to be. Now before I conclude, I want you to also understand something here. Like I said, organic chemistry is classified into hydrocarbon. And now, what are your hydrocarbons? We are talking about those compounds that are basically made up of carbon and hydrogen atom. Carbon and hydrogen. Only, that is the compound. Now, but when we talk of your non-hydrocarbon, there can be presence of any other element outside your carbon and hydrogen. That is what makes something non-hydrocarbon. Just the way it sounds, hydrocarbon, carbon hydrogen, or hydrogen carbon, something like that. Non-hydrocarbon means there is no calculation like presence of another element in between. So you should take note of all these things. We are going to consider them one after the other with respect to their various chemical reaction, physical reaction, and all the hidden points that are needed knowing for the various exams. So I'm going to take a pause here. I want you to go down to my list and subscribe. Turn your notification button because I'm going to be making more of the uploads so that you have access to it and sit in your humble abode and enjoy it and keep enjoying your lesson. So with this, we call it a day. Thank you. Don't forget to refer people of like mind to this channel. Then share this video. Let it go viral. Share this video. Share this video. That's about promoting an academic sector of our country's economy. Thank you.